All right, we are back, day 2, Pythagorean Theorem, with real-world problems. Real world meaning, I guess like word problems. I hate that kind of word. But when are we going to see this? Why would I ever use the Pythagorean Theorem? Where do 90-degree triangles show up in real life? And why would I need to find missing side lengths? So my essential question is going to be, can I find missing lengths in a real-world scenario? So we're going to be talking about houses, TVs, and ladders today. So where do we see these 90-degree triangles? If I don't see a 90-degree triangle, can I make a 90-degree triangle, etc.? Let's start with the most classic Pythagorean theorem word problem. It's hard to say word problem and real world problem like all at once, but the real world problem has to do with a ladder. And so I'm going to write out the long question here. If you want to kind of wait until I'm done and then put it in your own words or abbreviate it, you can. I don't know why I put that there, a 20-foot ladder leans on a wall 10 feet from the bottom of the wall, or the base of the wall. How high up the wall does the ladder reach? Oh no, I'm running out of room. Reach. Okay, so hopefully while you were either writing that or now you have paused it and you're going to write that right now, we need to figure out what does this picture even look like. So here is a wall. Here is the ground. And I'm going to label these, even though it kind of seems silly, like, okay, I know what the wall is, I know what the ground is. Because a lot of people forget that a ladder leans. A ladder is not 90 degrees to the wall. If the ladder was 90 degrees to the wall, it would stick out straight like this. And that doesn't work. And a ladder is never going to be 90 degrees with the ground. You're never going to see a ladder just floating. It needs to lean on something. And so I'm going to try and use a little bit of colors here. The ladder is what's going on right there. I'm going to try and use some colors so that you can see it. I'm going to draw a little picture here. Maybe it's easier to visualize that way. So the ladder is leaning on the wall. The wall is 90 degrees to the ground. And now we're going to label it a little bit. So it's a 20-foot ladder. It's 10 feet from the bottom of the wall. And it wants to know how high up the wall does the ladder reach. So how high up the wall is x. So how high is that x when we're looking for how high x? That's going to be your wall side, because how high up the wall if it's 10 feet from the base of the wall. And like I said, I think I said that like 2 times, 3 times the last time we were together, redraw the triangle. We just drew a whole bunch around it. We had lots of stuff going on. Just rewrite it so that you have a simpler, smaller version to kind of lean back on. That was not intentional, like leaning. Get it? Leaning? The ladder's leaning? Okay. All right, so we have our hypotenuse, which happens to be 20, and my legs are 10 and x. So I have a squared plus b squared is equal to c squared. What goes in for a and b? It does not matter which one is which, but one of them is x and one of them is 10. And it does not matter. You'll get the same answer no matter what you do. Okay. And at that point, I could cover everything else up and say, okay, solve that problem. Simplify the terms first. That would be 100. That would be 400. I could type those in my calculator. You could do it in your head. Still trying to get x squared by itself, so I'm going to subtract 100 from both sides. And I'm almost done then, because I almost have x by itself. What do I have to do? My very last step. Square root both sides. And you are then left with x is equal to the square root of 300. Why am I not accepting that? Because it's not simplified. What perfect square goes into it? 25 does, 4 does, and 100 does. And I like 100 because it's the biggest. 103, and why is 100 really nice? Because it turns into a 10. Going to remind you over and over again on our distance learning journey, if we got through that whole problem and you're like, whoa, I want to make sure I really understand that, pause the video right now, rewrite make sure you've got everything. If you might have missed something, rewrite it, and make sure that you're understanding this before you move on. So we have example 2 here. Example 2 has a little house. Might run out of room, might have to go to the back on this page. Okay, so we have a little house. Why don't you draw a little house? The bottom of the house actually doesn't matter. We're just going to be worried about the roof piece. So the diagonals on my roof are both 30. And then the whole base of the roof is 40. So from there to there, it's 40 feet. Let's say it's feet. That's a small house. That's okay. Okay, so I want to know, what is the height of the roof? And you are going to set up the Pythagorean Theorem, and you are going to solve for what you're looking for. Now here, there's a rectangle, there's 2 triangles going on, there's 3 triangles actually. What are we going to be talking about? I think I mentioned this quite a few times in our last time together. Pick a triangle. It's involving everything that I need to know. It also involves a 90-degree angle that includes what I'm looking for. Redraw that triangle somewhere as a way for you to simplify your drawing. So I know that that's 30. I know that that's x. What is this measurement right here? And if this is an isosceles triangle and that's 40, it's going to cut it in half. So that's 20 feet. And at that point, I have a 90-degree angles. Let's use the Pythagorean Theorem. 90-degree triangle, 90-degree angle. A squared plus b squared is equal to c squared. What is my c? It is 30, because that is my hypotenuse. And then for the other 2, it doesn't matter. X can go in for A or B, 20 can go in for A or B, doesn't matter. At this point, man, I'm struggling with words today. At this point, you are just going to get x squared by itself by subtracting 20 squared from both sides. I prefer to do this piece first. I prefer to say 20 times 20 is 400. 30 times 30 is 900. I prefer to write that piece out. But if you wanted to just skip to this part where you subtract 20 squared from both sides and you say 30 squared minus 20 squared, you'll get 500 the exact same way I'm going to get 500. Subtract 400. X squared is equal to 500. I am almost done. What do we do to both sides? Square root. X is equal to the square root of 500, but nope, not going to accept that. Why would I not accept that? Because it's not simplified. We want the square root of 100 and the square root of 5, because 4 goes in and 25 goes in, but we want to pick the biggest one. And at that point, x is 10 roots of 5. Again, pause the video if you need to. There's one problem left. This one might be a little bit easier. This one is a TV. Well, there's nothing there yet. It will be a TV once I draw the TV. So we have a rectangle. The sides of the TV are 20 inches and 21 inches. I don't think that this is actually a real TV size. Some of you guys are going to be like, actually, that's not right. But whatever. Okay. It wants to know, what is the length of the diagonal? Well, there is no diagonal. Oh, I'm running out of room here. Sorry. What is the length of the diagonal? Well, there isn't even a diagonal. So first we need to draw the diagonal. And I don't know what that is, but I know that there's two triangles. And when there is, I want to just pick one out so that I can use one. And then I don't have to like worry about like fidgeting with like 5 different numbers and too much. So I have this 90-degree triangle. I know it's a rectangle, so I know that that's a 90 degrees. This is 21, and I'm looking for the diagonal measure. And what is this side length? Well, if this is a rectangle, if that's 20, that's also 20. At this point, you have more than enough information to set up a Pythagorean theorem. A squared plus b squared is equal to c squared. In this case, c is actually what we're looking for. We're looking for my hypotenuse, and we're given my 2 legs. I'm going to finish up the rest of this a little bit quieter so that if you want to kind of keep a step ahead of me, you can. So all I did was I simplified those terms, so I'm going to add them up. And at this point, I could start going. I could say 841 divided by 4, 841, because I am going to square root both sides. So the square root of 841 is equal to my measurement, but by the time you take out your calculator, it's always good to start with this. Start with, what is the square root of 841, right? That's what we're doing. It's 29, it's a whole number. That makes your life way easier. So my missing measurement is 29 inches for that diagonal measurement.